Good evening. Good morning, everyone who's calling in. We're going to give folks coming into the Zoom room time to get situated. Adrian, are our cameras set? Do you have them set in speaker mode right now? Good evening. Yes. Good morning. Great. Good. And welcome to our Where's the Water Wet Season 2023 event. Again, we're going to give folks some time to come into the room. If you are interested in listening to tonight's webinar in another language, we have currently Chinese, English, and Thai available, and Lao as well. Our Khmer and our Vietnamese interpreters will be joining very shortly. And to join the meeting, you want to select the interpretation button at the bottom of the Zoom application and choose the language that you want to listen to. Right now we have Chinese, Lao, Burmese, and Thai available, and Vietnamese and Khmer should be coming in the room very shortly. So why don't we get started? My name is Brian Eiler. I'm director of the Stimson Center Southeast Asia program, and also our Energy, Water, and Sustainability Program Director. I am also the co-lead of the Mekong Dam Monitor, and I'm on behalf of my fellow co-lead of the Mekong Dam Monitor, Alan Bassiste. I want to welcome you to our seasonal briefing. Importantly, this briefing is on the record. We encourage media to attend this briefing to learn about, one, how dams impacted the Mekong over the previous dry season, and then how they're impacting the Mekong during the current wet season. Importantly, tonight we're going to take a deep dive into some climate factors to look at how climate's also impacting the Mekong and river levels in the Mekong. And we're going to talk a little bit about something called El Nino, because there's a lot of discussion about El Nino, and what Alan and I are seeing is some confusion about how El Nino is interpreted. So we've invited an old friend, Nguyen Hoa Ki from Vietnam, to join us, and he'll be talking to us soon about El Nino. And I can't wait for Alan and Hui to have a conversation about the weather. You know, all around the world, we talking about the weather as a form of chit chat, but wait till you see these guys talk about the weather. It's going to be something different. We're going to be here for about an hour and 15 minutes. We've got a half an hour set aside at the end for discussion. And unfortunately, one of our panelists, China Pon from Asia Disaster Prevention Center in Bangkok, last minute wasn't able to join us for a personal reason. So you've got to put up with a bunch of guys tonight. And I do want to say that this is not the Stimson way, folks. We want to have gender equity on our panels, but we wish we could have had another woman on our panel, but it just didn't work out for this particular event. But we will strive for that for the next event. All right, well, we're going to jump right into things, and I'm going to invite my teammate, Regan Kwan, who runs the data and the back end of our Mekong Dam Monitor, to give a brief overview of the new features that we've added to the Mekong Dam Monitor since we met you last at our previous Where's the Water Dry Season 2023 event. Regan, over to you.
Thanks, Brian. And thank you everyone for joining us tonight or this morning, depending where you are. As Brian noted, I'm just going to briefly go over what we have new on the Mekong Dam Monitor. And a lot of that started with our work, which was supported by USAID Wonders of the Mekong. This is this 3S basin analysis of hydropower impacts on the Mekong. And through this analysis of 20 dams, we're able to add new features to our Mekong Dam Monitor platform. And you can find this report on our website at stimson.org. And you'll find very interesting facts and new findings that our team was able to include, as well as interesting little data analysis tools and other features that we've included into this very interactive report. As I said,
Regan,
yes.
do you want to show everyone that metro map? I think the metro map in that report is a pretty good way to talk about dams.
That was what I was thinking about when I first mentioned that. It should be here we go. So this is a metro map. Oops. There we go. So this is a metro map, similar to, for anyone who's ever taken metro. There's a map of showing all 20 dams that we are monitoring at the moment from the 3S basin within their countries, as well as how each of the river in the 3S basin is currently located and how it flows into the Mekong. And if you were to click on any of these dam locations here, for example, Lower Saison 2, it's going to pop up with great detail about some of the general information about the projects. As you can see here, you'll find additional charts. It's the weird look on this chart is a function of my small monitor, but it looks much better when you have it on yours, as well as an additional detailed analysis that we provide for each dam. So this is a really great function that our comms team supported us on in this report, and we're really happy with how that's turned out. So again, if you'd like to look at this, please feel free to go to our website and you'll find this under our Mekong Dam Monitor project page. So from this report, we created a couple of new features. The first one, of the 20 dams, 10 of them are completely new and were not monitored in the Mekong Dam Monitor previously. You can now find them in our virtual gauges tab under the dams and reservoirs. You can scroll down and you'll start finding them as you get lower, and they will include the same information backdated to around 2016, 2017, or later, depending on when the dam started. So we do have historical data on all of these dams as well. Finally, we have updated our cascade analysis. These used to be static maps, but as you can see here now, they are now interactive charts that you can hover over and get week-to-week information about each of the dams and how they've operated, depending on the cascade. So here, for example, this is a Langsang Cascade from 2016 to 2023. These are those 11 dams in China. And we can go over every single period around here. You can also interact with the chart. You can turn off certain dams or toggle or go for extremely short periods of time within this time frame itself. For example, if you wanted, we can just keep on the two largest dams and you can see kind of the impacts that they have. You can zoom in to a certain specific point to get more detailed information depending on the time of date. I'm going to reset this. And then you can also turn everything back on. There's also the option to download the data if you were to click down here and download the charts. If you were to go to the top right position, I believe this function right now is under repair, so we do need to fix that for anyone who's interested in downloading any of these charts. Finally, you'll also notice that we've also included other cascades. The 3S basin, as I just mentioned, is also another component now, and you can see all of 20 dams that we've included through that from 2016 to present, as well as each basin within the 3S basin. So we'll have a Mekong, Saison, and Sraipak as well. So please, if once this event is over, or if you want to do it during this event simultaneously, please feel free to take a look at these new features that we've included. And we look forward to any feedback that anyone has or anything anyone wants to reach out to. Please feel free to do so after this event. Thank you.
Thanks, Regan. And for those of you who are interested in that cascade analysis, we're going to be adding more. We're going to add in the Thai cascade, all the dams in Thailand. That's kind of one grouping of dams. And there are some other tributary systems in Laos that are now able to be estimated in this fashion as a cascade. All right. Well, let's jump right into tonight's presentation. What we're going to do is talk about where the water is. Let me get to the beginning of my presentation quickly here. Share screens. Okay. And just as a reminder, what the Mekong Dam Monitor is an open source online platform, fully open to the public, that uses different kinds of data inputs, mostly generated from satellite imagery and remote sensing technology to monitor 55 dams throughout the course of the river, including tributary dams. We're looking at the largest dams. And we also model natural flow. So we imagine how the river would flow given current conditions, current wetness or precipitation conditions. And we provide information about climate information too. So when you're going through the Mekong Dam Monitor, you're able to get a feel for how dams are impacting the river, how climate is impacting the river, how the weather is impacting the river too. And those are the things we're going to talk about tonight. But I just wanted to start with some highlights, some interesting findings from the previous dry season. One, this is kind of a demonstration of how the remote sensing radar imagery works. Here, Regan has strung together a 6-week period of observations of water at the Nam Kong 1 dam in southern Laos. And you're seeing from February to April, it drained nearly all of its water. And this was very puzzling to us. We don't know why it dropped its reservoir levels so low, much lower than ever observed before. But we were able to observe it. And, you're looking at like a 30-kilometer long area there of that reservoir. And as it released water, we assume it was producing hydropower because that's what dams do. And the reservoir now in the current part of the wet season is slowly beginning to fill. So this is just a demonstration of what we can see from outer space with this freely available data. And then another interesting find was kind of a combination of what Alan and his team does and plugs into the dam monitor and what my team at the Stimson Center does to plug into the dam monitor. In April, Alan and his team detected a rapid snowmelt event, and that's demonstrated by the orange and yellow at the top uppermost parts of the Mekong Basin in China. And at the same time, our virtual gauge process, which Regan and I managed, found a sudden increase in a dam at Huangdong, which is the 3rd largest dam in China, sudden increase in reservoir level. So to us, it was really kind of neat to see these two forms of data input speaking to each other. A massive snowmelt event sending lots of water into the river system in April because it was hot out, and then that downstream dam catching that water and using it to fill up its reservoir. Now, if the dam weren't there, that water would have flowed downstream and fed kind of early wet season boosts into the downstream. Instead, it was caught within that reservoir. Another big find that we actually talked about in our last Where's the Water event was a discovery that during the wet season of 2022, China's dams didn't fill up as much as they typically do. So if you look at that area inside of the circle, that's what happened in 2022 through the present. And you can see the peak of that small mountain there did not reach as high levels as previous years. So 2021 got to higher levels, 2020 got to higher levels, and this is the reservoir level, the volume in the reservoir increasing during the wet season. And you also see something interesting, that most of the water in China is held in 2 large dams. These 2 largest dams, Xiaowan and Nuojiadu, if you're new to our series, this might be the first time you've heard about them, but if you've been to our series and our talks before, it's not. These are kind of the 2 largest drivers of change within the Mekong system. Those 2 did not fill to normal levels. And that means that when the water is going to be used, typically during the dry season, in this case, the dry season of 2023, there wasn't as much to be used. So we saw this early on, and actually in December, we communicated this information and a kind of forecast to downstream government stakeholders and communities. And we were happy to talk to community leaders in the Golden Triangle in Thailand and say, there's going to be a lot less water coming down the system during this dry season. You might have somewhat of a normal dry season depending on how that water is let out. And interestingly, indeed, there was less water let out, because there's kind of a corresponding or reciprocal relationship between how much water is restricted during a wet season and then put down through the system during the dry season. Now, just to bring things into perspective, why we focus on China's dams so much is demonstrated in some of this new information that we produced over the last few months. We're able to estimate the active storage in 55 dams throughout the basin. And on the left slide, in the left image, you can see that the Lancang Cascade in China holds multiples more water than other groupings of dams in the downstream, like 2 large dams in Laos on the Nam Num River, 20 dams in the 3S Basin, Vietnam, Cambodia, and Laos, and so on. And you've got to kind of add all those other groupings up to equal how much water is in China. Now, even more interesting is when you break those categories apart and we just look at the largest dams in the system, it's really 2 large dams in China. And in fact, when we look at the largest dams in the system, there's the 2 large ones, which hold together more than 50% of the active storage in the basin. And then there's only 1 more in China, which is much smaller, the Huangdong Dam, than dams in Vietnam, dams in Thailand, and dams in Laos. So we focus on China's dams because they're huge and they can wield a lot of power and influence over downstream outcomes. So when you think of that bar, that's the amount of water that could be put into the system during the dry season for hydropower production or taken out of the basin during the wet season. And how much is taken out during the wet season typically is how much gets put back in during the dry season, depending on demand. And what we found is that during 2022, those bars just didn't fill up as high. They didn't get anywhere close to their high points. Now, this how dams are operated can first be seen in something that Alan produces, and that's the natural flow model for the Chengsang gauge. And actually, our team got to go there for the first time together last weekend. It was such a treat for Alan and me and Regan and Courtney and the team just to stand there and to think about the place that we watch from afar. And this is actually a photo that I took standing there with all of them. This shows very clearly that what we forecasted and predicted in December played out. So the way to understand this is that the yellow line is the observed flow. So that's how much water was observed at the Chengsang gauge. And then the blue line is how Alan models or imagined the water or the river would flow under natural conditions. So when the gauge is higher than natural conditions, that means there's more water in the river than should be there. And that's done from dam releases. Now, the line is just slightly above the blue line, which means there was not so much water added in. Previously, if you look at other natural flow models from previous years, you see mountains of water, and the distance between the 2 lines is huge. We just didn't see that this year. And we also heard from local people in the Golden Triangle that things like the local algae harvests were somewhat normal this year. It was pretty good. They were able to harvest algae out of the bottom of the river for food, somewhat similar to the way they used to when the river flowed more naturally. Now, indeed, there were ups and downs, and indeed, more water was added into the river system. And what's interesting is we're now able to analyze how dams are impacting the river farther and farther downstream. So what we've done here is chosen 5 different stations along the river, and we've moved China's dam releases for hydropower down the river, and also incorporated the dam releases that happen during the dry season from the downstream, from those dams in Laos, Thailand, Cambodia, and Vietnam. And what's interesting is that for the entire 6-month period of the dry season, China's dam releases raised the level of the river 1.4 times the amount of water that should have been in there. But interestingly, if we go month by month, you're going to see that December had the greatest releases, and then other months were quite low. And as we move downstream, there's more water that's put into the river system. So China's impacts raise the level of the river proportionally less and less. 57% increase of flow at Vientiane, 33% at Nakhon Phanom. In Nakhon Phanom in Thailand, we get to see the lower dams start to influence. So together, those two sets of dams raise the level more than 50%. And then Paksay, another 50% increase together. Stung Treng, what's that, about 46%. So there are significant increases to river level happening, even though China's dams released less water than normal. So we're seeing the impacts of the lower dams too play out. And one of the consequences, and we've talked about this many times before, is that the river level is rising to unnatural levels downstream. And in places like Cambodia, what's known as the flooded forest, right across the border from Laos, those flooded forests are dying. And these flooded forests have important social value for communities, fisheries, biodiversity. Some of the world's most amazing yet endangered bird species live in these flooded forests, and freshwater dolphins thrive within these flooded forests. Cambodia is pursuing protection of the flooded forest with an application to the UNESCO Natural World Heritage designation. But if this type of trend continues with releases during the dry season, then these trees, their peril is obvious and imminent. So it's important to consider and recognize the impacts that dry season releases bring to the downstream. Now, interestingly, if we go month by month, you got to remember that these dams don't release water in a consistent manner. They're releasing more water in one month than another. And at the same time, the river level, the natural level during the dry season should be going down. So for example, in January, we see a kind of a natural flow level at Changsan that's higher than February because the river would be going down. But because of what dams are doing, the decrease in level is not as drastic as what it should be. So this is kind of just showing month to month how these categories of dam releases upstream in China, all the downstream dams are affecting flow. You can see in Paksay in January that I'm trying to move my screen around so I can see all the numbers. Downstream dams increased flow by 23%. Stung Treng was the downstream dams that drove the most change in January. In February, 84% increase at Changsan, but that translates to just a 16% increase at Stung Treng farther downstream. It's the downstream dams that have the biggest effect. Again, it's not like this every year. And it would be great to think that someone in China is saying, hey, let's release less water because the downstream levels are important to be low during the dry season. We don't think that was the case. Rather, we do think it's a result of just less water availability from the previous wet season. But it's possible. And if that is the case, then someone upstream should be commended. Regardless, the impacts were less intense during this particular dry season out of China. And therefore, the downstream impacts were much more intense. I mean, look at April, 47% increase of river level at Stung Treng. Okay, moving right along. Let's go back to Stung Treng, and I'm about ready to pass the baton over to Alan. But before we do that, we want to think about actual movement of water. Those previous slides were just kind of stock analysis. So we took like how much water is released from China's dams during the month of January and put that on top of what flow was observed in January. We didn't apply any lags, but importantly, it takes time for water to move from China all the way down 2,000 kilometers to Stung Treng, Cambodia. So what we did for China's releases is we put a 2-week lag on the traveling of water because we have observed that it takes about 2 weeks on average for water to move from China to Cambodia during the dry season. It speeds up during the wet season, but 2 weeks for the dry season. And then we put a 1-week lag on the downstream dams. And we came up with some interesting results. One, and importantly, the bottom line shows how the river would run under natural conditions at Stung Treng. And you can see under natural conditions, you have this nice downward slope that the river level is decreasing. And the nadir, or the bottom of the river level, happens in April, which is kind of a normal month, right? For dry season lows. It's why New Year's in the Mekong is celebrated in April. It's why the water festival happens, because there's water that's needed. And then lo and behold, after April, the water comes back and the wet season arrives. But what dams are doing is the yellow line. That's the actual observed amount of water. And they're creating a higher and earlier low point. And this is changing the timing of how the river flows. And it's very concerning. Just some numbers to point out later on in the year. Earlier in January, we see the impacts of China's dams, right? 38% increase of flow. But later on in the dry season, just a 1% additional increase, a 14% additional increase. And it's the downstream dams that are changing things the most. Now, during a normal year, China's dams can have as much impact as those downstream dams. So China's dams could add another 100%, double the amount of water. And that's when those dams work together to really change the flow of the Mekong. So that's a brief overview of what happened during last dry season. I'm going to turn it over to my colleague, Alan Bassis, to bring us into the wet season. Alan, over to you.
Thank you, Brian. That was a good overview and hopefully a good segue to the next section of our presentation. And that is how basically the wet season developed, and then how basically the lower flood poles in the Mekong dried out as the wet season ended and we moved into the dry season. So we have a series of plots. On top is from SAR. In the blue is our dots of where water is inundating the surface. And this is actually areas that are noted as wet surfaces. The bottom series of plots are from the surface wetness calculation, and this is a slightly different product. It's telling us basically how flooded the surface is. So it's not exactly which spots are wet, but the larger area and how the lower Mekong flood pulse is inundating the surface and covering more and more area, and then drying out as the wet season ends and we move into the dry season. So let's run across the top plots very quickly. And you can see from October to January, you can see quite a bit of drying out as less and less blue spots in the lower Mekong basin. April even drier, and July, unfortunately, as the wet season should have gotten well underway, but July, the wet season is actually quite delayed. And so the flood pulse is reflecting in that. If you look at the lower plots, and you could see the dark blue, that is the areas that are completely flooded, and then it goes into light green, which means partially flooded areas. And you could see that around the Tonle Sap Lake, it's completely inundated. And you can see that the dark blue goes down all the way into the delta of Vietnam, and where a lot of irrigation takes place, and they're dependent upon that water for agricultural practices, keeping the salt water out, and other reasons why that flood pulse is so essential to their needs. You see how that it's drying out into January. You can see most of the blue is gone. So that surface is getting much drier. And then you can see in April, yet drier still at the end of the dry season. Most of that water has moved out of the Tonle Sap Basin, out of the Delta of Vietnam, and basically moved into the ocean. And so the surface is quite dry. And then July, we should start to seeing it wetting up again, but it's not. And that is part of our concern right now. We're into the wet season, and yet you can see that July, the flood pulse is actually not there. And you can see it on the next plot very clearly. And let me explain to you a little bit of what we're seeing here. We're seeing on the left-hand side, if the water is flowing out of the Tonle Sap Basin, then the black area shows the magnitude of the outflow. So you can see early in 2022, you can see that there's outflow. And then a little bit of, and put on some glasses so I can give you some dates. Around in August and September, there was a small reversal of water coming in from the Mekong, but the reversal was quite weak. And then by the time we got into October, the Tonle Sap Lake was higher than the Mekong main stem. And so the Tonle Sap Lake was flowing out again towards the Mekong. So very little reversal. And most of the water that was flowing, that rose the level of the Tonle Sap Lake came from the Tonle Sap Basin itself. It didn't come from the Mekong. So you didn't bring in the spawn, you didn't bring in the larvae, you didn't bring in a lot of nutrients and sediments to basically to bring fertility and into the Tonle Sap Basin. Very little reverse flow, and most of the water that's coming out of the Tonle Sap Basin flowed out of the Cardamom Mountains and the area surrounding the basin itself. Over on the right-hand side, you can see the relative years, and you can see the maximum in black, and you can see the different months, different years, and how this year compared over the minimum. And the blue line is what we're tracking right here. And so we can see that basically the water levels at the Tonle Sap Lake and Pret Kadam are very low relative to the long-term average. And that's a deep concern, because we should start seeing the Tonle Sap Lake rising. We should see a lot of water coming in, but in reality, that's not happening this year. And so we're on very depressed levels of basically water in the Tonle Sap Basin, which has a direct correspondence to the amount of fisheries and the fertility of the lake and the communities that depend upon fish for their livelihood. We've moved on to another plot, which is basically, this is from the MRC. It has nothing to do with satellite data, but the two complement each other very nicely. So let me tell you a little bit about what you're seeing on this plot. You're seeing the blue line on the very top is the observed maximum reverse flow, basically a 10-year period. And then you could see the blue line at the very bottom is the minimum reverse flow over the 10-year period. And of course, the black line in the middle is the average. So you can see that there's a nice spread over the 10 years. But look what's happening. This yellow line at the very bottom is what's happening this year. So you can see that this year is lower.
Well, Alan, we're losing your audio.
And the 10-year minimum, and well below what happened. Hopefully you can hear me again.
It's breaking up.
Can you hear me? It is breaking up.
Yeah, could you try to turn your video off?
Yeah, I did.
Actually, now I think it's okay. I think we're back.
Good. Okay, so let
Keep
me try to go back and say just a little bit of what I lost when my video died. This yellow line, which you can barely see, shows how weak the reversal is this year. And remember, last year the reversal was quite weak. Even though the Tonle Sap Lake rose to high levels, it was not from most of the water was not from the reversal. It was from what happened around the high precipitation around the Tonle Sap Basin. So we're in very low reverse levels right now. The Mekong River is quite low, and the Tonle Sap Lake is also quite low. So there's very little water relative to the previous years. And we're deeply concerned about what that has as far as impact in the fisheries and the whole community that depends upon the water. Well, here's a larger view of what's happening in Southeast Asia. So what's happening in the Mekong is not independent of what's happening in Southeast Asia. And this is going to go into the impacts of El Nino, which is starting to have an influence on rainfall patterns in Southeast Asia. So the dark red means less than 5% of the time is it that dry at this location. So an extreme event. And you can see that the extreme events are happening in around Cambodia and northeast Thailand, up into the headwaters of the Mekong Basin, in Bangladesh and parts of India, extremely dry. The monsoons are not coming in as usual. So there is a global signal that's happening in the Mekong Basin that ties more directly what's happening with the beginning of a El Nino event and the impacts on water supply. So if you could see it over the course of the last 4 weeks, again, the dark red is extremely dry, and conversely, the dark purple is extremely wet relative to the long-term 30-year average. And so you can see that in July 1, it's dominated by red, and that red gets more and more amplified as we move into the 8th to the 15th and to the 22nd. So look what's happening around July 22nd. We're seeing an amplification of the extremely dry conditions throughout much of the Mekong Basin. And of course, this is going to have a direct impact on the amount of water that's available for either filling the dams or maintaining a healthy wet season flow. And then the lower plots are temperature anomalies. And you can see that temperatures are generally, the brown means temperatures are warmer than average. So these two signals complement each other as far as understanding what's going on, dry and hot. And let's look at it relative to many other years from 2019 to 2018 and 22. So right in the middle is July 22nd, 2023. And we can see that our concern in 2019 was that a very dry year. 2020 was a dry year. Compare that to 2018, where we're actually seeing quite a bit of blue. So above average wetness, above average flow, and a very healthy reversal and wet season, basically flood pulse in the lower Mekong Basin. 22 was also a relatively wet year, particularly around the Tonle Sap Basin. It was dry up in the headwaters and in the upper basin, and dry in a good portion of Laos and part of Thailand. But around the Tonle Sap Basin, they had an excess amount of rainfall, and that's what allowed the lake to rise independent of the reversal. And we're not seeing that in 2023. We're seeing very little blue, and we're seeing a lot of dryness around the Tonle Sap Basin in northern Thailand. In fact, throughout much of the basin, we do not see much blue, and we're seeing basically deficit moisture, which is deeply concerning because we're well into the wet season and the rains are just not occurring the way they traditionally do at this time of year.
But thanks, Alan. Just to round things out, we put the 2019 and 2020 wetness anomaly up there because those were two of the hard years, right? There were 3 hard years in a row, 19, 20, 21, extreme low flow. And Alan and I have been staring at this July 2023 map, and we think it looks a lot like 2019 and 2020. So it's very concerning. And what we're going to talk about next is forecasting into the rest of the wet season, and things don't look good. All right. So we're going to learn about that. But another thing to think about is water availability. So reservoirs at this point in time typically take water out of the system. So if there's an extreme drought downstream and you take water out, then those dams are going to exacerbate drought. So for example, you see the largest dams here on the left chart, and you see an uptick over the last week. Those are from lower Mekong dams and the Xiaowan Dam. They're starting to restrict water, and that's going to exacerbate drought. But the availability right now is not high. So there's not a lot of relief that can come from dams if relief is needed. So the dams are in a position where they really can't help. If they take more water out, they're going to hurt. If they let water through, they're helping a bit. Okay, so perhaps it's important to think right now how these dams could be operated so they don't exacerbate these emerging drought conditions downstream. And just to bring it home to the big dams, the two that we talked about earlier, here in the last 2 weeks, Xiaowan increased its reservoir level by 17 meters. So it was taking water out. Norjadu, interestingly, let some water out last week, and that's actually helping the downstream. But the net difference is still more water was taken out. And we saw 1 billion cubic meters of water removed from the system last week. That's going to come in the dry season, but the water's needed now. All right, we're going to turn it over to Dr. Hui, who's going to talk to us about El Nino and what we might expect for the rest of the wet season. Hui, over to you. Hui, you're muted.
Can you hear me now?
Yes, thank you.
Yes.
Thank you. Thank you, Brian. Thank you, Alan, for the brief situation of the water in the Mekong Basin. And now I would like to turn into the brief information about the forecast of the rainfall in the coming month, based on of the El Nino chance forecast, and try to see that how the rainfall look like in the coming months. And in this prediction, we will have a 9-month forecast based from August to from August 2023 and to next year April. First of all, I would like to share with you the evaluation of the answer from 1992 to 2023. What we have been observed so far is that since 1993, the answer is mean the normal time of the weather is happened in very short periods, and during from 1990s until now, it's have 9 events of the El Nino and 9 events of the La Nina. This means that La Nina turned into a short term of the answer, and then continue with the El Nino, and just turn over between of the El Nino and La Nina. And you may know that La Nina bring more water to the Southeast Asia countries, and El Nino is like less of the water, less rainfall, and more heat, more temperature increase in the regions. And it makes a comparison. The most several events had happened. It's at the 2015 and 2016, and was the time for the strongest El Nino happened in the regions. And the anomaly values temperatures were plus 2.6 degrees Celsius, and the most event happened were 2019 and 2020, and you may still remember the drought happened in the regions recently. But in the last 2 years, actually 3 years, 2020 and 2022, that was the La Nina periods and lots of water. And here's the prediction for the El Nino in 2023 and 2024. We based on the data from NOAA, observe that the El Nino condition is now present, and also there is a greater than 90% that El Nino will continue in our region until by the end of the spring next year. And the problem is that El Nino will happen during the normal dry season in the Mekong Delta basins. So it is predicted that it will bring a source of the water during the coming months and until the early of the next year. And this is based on, if you see in the paragraph, it is based on observe more than 15 model, and we can count the average values of the El Nino for this year. So the red line in the middle is the average level of the El Nino this year. And if we make the comparison with the strongest El Nino in 2015 and 2016, we will see that in this current El Nino, the value is lower. It is predicted that 1.5 or 1.8 degree Celsius compared to 2.6 degrees Celsius in 2016. So it means that this is a normal, you know, it is strong El Nino, but it's not strong, not strongest one. It's not strong compared to 2016 and 2015. And El Nino is predicted to be end by April of 2024. So by this time, it will be end. And we are worrying that when the El Nino is end, the La Nina will continue. That will be the problem of the too much water dumping into the into the Mekong regions. How the El Nino affect to the Mekong regions? So the data observations from last December until now showing that we are lacking, you know, the less rainfall in the Mekong River basin since December 2022, including in the past, the northern west, the southwest of the China, in the whole countries of Vietnam and Laos and Cambodia, Myanmar and Thailand. So the whole season have less water, less rainfall, is around, you know, from 50 to 200 millimeters per month if we compare to the normal. And also we also observe that during the June and July, the amount of rainfall in the regions, you know, a little bit higher than normal. So that is the reason why we have some observation that is much more rainfall in the last 2 months. But the problem is that the amount of the rainfall even is higher than the normal, but it's not enough to fill in of the lake. And that is the problem of the many reservoirs will dry up in the last 6 months. And this is the forecast data. As the data are calculated by on of the model of the 12 forecast member indicated that, and it's predicted that almost of the zones in the Mekong deltas basins have a less rainfall in the next 9 months, and it's less than like from 30 to 100 millimeters per month. And during the August of the 2023 and April 2024, it compare with the normal years. The problem is that less storm circulation hit to the Indochina regions, because when El Nino happened in, you know, we will make the comparison with the La Nina years, we will see that the number of storm happen and brings water into the inland is less than the normal year. And the El Nino happened during the normal dry season. Is it coming from this time? Or maybe from in some region it's come from October or December. So is that will be several drought, and it brings consequence of drought and salinity intrusion in the low Mekong region in the late of the year 2023 and the early year 2024. And here is quite a bit detail. I will go it quick because of the short of this time. Just showing you in the different month from August to this year to April next year. We see that in many places in the Mekong River basins, have a less rainfall than normal. The green color, blue color indicates that it's the amount of rainfall is higher than a more normal year. The dark color and the Dutch color indicates for the lower rainfall in the normal. So this data it can calculated by on the 12 model and so this one, and you see that in the whole region here in the northern part, the wet and the east of the upstream Mekong river system have less rainfall in September. So we would have 2 continuing years, a month, lack of rainfall. So there will be, lack of the water, fill in the reservoir and the dams and the hydropower system as well. And luckily in October, we will have some good signal of the blue and green here. However, it's still it's not significant. It's like just more than 20 millimeter or 30 millimeter per year. Sorry, per month. So it's not even it's higher, but it's not significant. And here, the actually it make the comparison with the normal the central highland where bring the water to the Mekong Delta and Mekong River system, also lack of rainfall during up to November. One important thing is that the forecast showing that the rainfall in some parts of the December is higher than the normal years, but the problem is that good dry season, and even it's higher, but it's not significant water contribution to the water system in the Mekong Delta. And you will see in this photo showing that the dark color is nearly in the beginning of the lands of the Indochina regions in the Mekong basins, and it means that the chance for the dry could coming up in during this time. And in February, it is almost it's like the normal of the years. I don't know, but the model showing this, even if we make the comparison with the other El Nino, during up to February, there will be lack of rainfall in the upstream of the Mekong Delta and including in the downstream of the Mekong Deltas. February as well, there will be lack of the water in these regions in the Mekong Delta. In March, it's continuing of the lack of the water. It is, it's less than the normal year, just maybe 20 millimeters per year, but actually it's during the dry season. So the signal we'll be bringing here is that it's still the problem for the downstream of the Mekong Delta in the condition of the drought and salinity intrusion. And here's in April, we still like in the low Mekong Delta that will also have less of the water because of less rainfall during this time. So this is the end of the prediction that we have so far. So thank you very much, and waiting for the discussion with you.
Thank you, Hui. Wow. What excellent data. I'm afraid you don't have a good story for us, though, given the prediction is not so good for the rest of the wet season. We've got a number of questions here. Before we get to them, Alan and Hui. Alan, do you have any questions for Hui?
Yes, I was curious, the map that you showed in August, it showed a wet stripe coming down into northeast Thailand and coming down and through Laos. And I'm curious, in the model, what would cause a wet area surrounded by a dry to the east and dry to the west?
Sorry, can you indicate the month? The month again,
I think it
August,
was the
right?
month of
August.
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 Yes,
Yeah, right.
August.
Right. So in the month of the August, prediction indicated that there will be very low rainfall in the low river basins system, including Cambodia and east of Thailand and Laos. Actually, it it in the east of Thailand and Cambodia. Normally, you know, in August, from August, if the typhoon come from the oceans across the Pacific region, across the Philippines, and it's coming to the east sea of Vietnam, and then hit into the land from in the the late of the summer. How is the mode of the typhoon will be going to the northern parts of Vietnam or the central north of Vietnam, and then to Laos. It's not distribute water into the low river basin in Cambodia or in Thailand. But we will need to wait until the late typhoon season, the storm season, saying that it will be October or this or November. So the typhoon tracks, the typhoon, wait focus to the from the east to the west, or from the east to the west south, to the southwest, and then after August, maybe there would have some of the water from the typhoon circulation to bring the water in that region. That is the reason why, it's less of the water in the downstream area during of the August. Thank you.
Thank you. And then one quick question. I know that time is limited, but we've and this is a question to you. We've noticed that the trade winds coming off the South China Sea are strong, and that there's been a fair amount of rainfall in Vietnam. However, the normal pulse of rainfall coming out of the Gulf of Thailand moving north has been very weak. So the circulation pattern, it looks like, has been disrupted from the normal pulse of rainfall coming from the south to the north, but more rainfall is coming across from the trade winds from the east to the west. So it's a disruption of the whole circulation pattern and rainfall pattern that is promoting dryness in the majority of the Mekong basin. So this is what we're seeing, but I wanted to get your point of view of what you're observing.
My observation, so like try to make the comparison from this year to the normal years. Actually, from during of the early summer, from March to July, so trade wind from the east south, from the Thailand Sea cross over of our country, or from the Bengal Basin cross to Myanmar or Laos, to the land in Laos, Cambodia, and Thailand. But from the typhoon season, it's like from August to the September or October, the trade winds from the China Sea, or from the Philippines, or from as you say, that from the southeast come to inland. That I think it will be the normal, but in this year it's not normally like that. What my observation is that the wind it come from the south to the north more directly, and that's reason why many typhoon, when it's formed, it's not hit into the inland, but it's turn directly to the north, or it's turn turn back to the ocean, by the direction of the northeast Yeah,
Mhm.
the noise, the direction of noise, and that reason why a lot of the water from the trade screen bringing into the lands of the Indochina regions.
Great. Well,
Thank
thanks.
you.
Hui. And Hui is just a fount of knowledge and wisdom on weather and climate and El Nino, as we've seen. One thing that I benefit from is following Hui on Facebook. You don't have to friend him, you can follow him, and he puts these amazing weather maps and radar maps up, and just it's one way that you can watch the system. Particularly those of you in Vietnam, you get a feel for how these easterly typhoons are hitting the coastline and affecting the coastline there. But one thing that I think we made very clear, and we've learned over the years, is that the Mekong's weather is not consistent throughout the basin. The basin is huge, right? It's 4,000 kilometers long. What happens in China doesn't always happen downstream. Last wet season, China had a severe drought. Remember all those pictures of people, walking across rivers in China in August of last year, while the Tonle Sap was expanding, right? The downstream had robust rainfall. And I think, Hui showed us some flip sides of that during his presentation as well. Times this coming wet season where weather in China might be robust, but extremely dry in the downstream. So let's go to the questions. We'll probably stick around a little bit longer, maybe 5 minutes more, because we have a lot of really good questions here. I'm going to start with one from David Dumaret in Australia, which is a little bit more of a comment than a question. And he says, are Lower Mekong Basin countries facing a loss situation? Are they losing their wild fish catch to hydro dam development because dams block fishery migration, and facing a loss of hydropower generation due to low water availability? This year, that's what it looks like, right? We're seeing that dams are not able to fill to their potential, capacities are low, and that translates into the inability to produce hydropower. So this needs to be taken into consideration, particularly for newer dams being built. Is this a form of power generation that will be reliable in the future, given how much water has been available and how water availability is changing? So great question, David. Let's go to just some quick questions from the top. Mai Chan at Radio Free Asia asked about reservoir levels not in the Mekong, but in rivers that flow into northern Vietnam, because rivers in northern Vietnam during summer 2023 were extremely low, and reservoirs there were unable to generate hydropower. So there was a significant loss of supply. Supply wasn't able to meet demand. And there was speculation, we heard it, that China's dams upstream were taking water out. So China does have dams upstream in the Red River, and also the Black, which are in Yunnan. Now we got to remember the Mekong and the Red and the Black are all in Yunnan province. In fact, they're quite close to each other. Can we think that what happened in the Mekong also applied in the Red or Black? It's possibly true that during the wet season of 2022, the Chinese reservoirs in the Red and the Black were also very low, lower than normal, just like the ones on the Mekong in China. So I would be willing to bet that it wasn't the Chinese taking the water out. They just didn't have enough. And then that translated downstream as well, that the reservoirs were low. So, what Vietnam was experiencing is the same thing that China was experiencing. But it is possible to watch those reservoirs to determine what actually happened. But that's a speculation. And again, I'd bet on my analysis there that China's reservoirs were low. Let's look through some other questions. Let's go to some that Alan and Hui might be able to answer. This comes from Anthony Green about El Nino. Anthony says the ENSO evolution seems to be in transition to the Nino and dry events. So if that strengthens more, we expect very dry conditions, but the predictions do not show much difference from normal. So how confident can we be in these GFS predictions? Hui, this is one for you.
Thank you. That's in the presentation that I am showing. I make the comparison between of the prediction for El Nino of this year and the El Nino the strongest El Nino in 2016 and 2015. The values of the El Nino in this year is expected to reach 1.5 or 1.8 degrees Celsius higher than the normal. But in 2016, it grew to 2.6 degrees Celsius higher than the normal. So it means in this year, so it will be the strong El Nino, but it's not the strongest one. But the problem is that, you know, after of the problem is that the time that El Nino happened, in this time, the El Nino happened when we running up out of most of the water in the river system, including China, the northern part of Vietnam, in the river basin in Laos, Cambodia, and also Myanmar. This is almost, you know, the condition of the drying up. And when El Nino happened during this time, it could bring a more severe problem for the river system. It's not only of the Mekong River system, but also other river system in the region. So even the value of the El Nino is not so high compared to the previous year, but the time it happened is a problem during a dry season. Thank you.
Alan, this is a question for you from Murray Hebert. Murray asks, how much is this just normal weather patterns? How much of this is due to climate change?
Well, there's always a challenging question because there is natural variability and there's year-to-year changes that you can't quickly put a label on it and say climate change. What we look for is trends, so that we look for the long-term average and we look for changes, differences from that long-term average. And some of the maps that we showed earlier, we showed a deeply concerning pattern of very dry in 2019, 2020, even 2021. We were seeing some very dry anomalies in the basin. And then we're seeing a fairly wet year in 2022, particularly in the lower basin. But we're seeing dry again in 2023. So when we look at many years in a row and we're starting to see a pattern, that's when you start to wonder, is this truly climate change? And you can't immediately say climate change because there are trends, there's variability, and then things can go back to more normal. But the models indicate that there will be a drying pattern. The prediction models, the long-term climate circulation models, are indicating that there will be a drying out in the Mekong Basin from the physics, from our understanding of the global circulation. And then we're seeing it in reality. We're seeing it in the wetness anomalies. We're seeing it in the dry events, in the persistent dry events. For many years, over the last 5 years, we're seeing abnormally dry. So this actually starts to be a concern that this may become more of a normal pattern and not just interannual variability.
Bree, what's your opinion? Climate change or normal weather?
Yeah. So I have been observed the El Nino for a long time ago, and also together with the data on the climate change. Indeed, it's actually the combination between El Nino and climate change. El Nino had been, you know, we know about the El Nino is long time ago. It's like not decade, but also centuries ago. But the climate change is new. When El Nino happened and combining with the climate change, it makes, you know, the problem become worse. Become worse, more consequence. If, for example, in this year, you would know that it's many places in the world that have a very high temperature and it breaks the records. And in Vietnam, the temperature will break the records during up the May and June. And also I get there's a model showing that, you know, in America the temperature will be also break the records during this time. Today or, you know, coming the next few days. It
Yeah.
will be more than 43 degrees Celsius.
Right here in
in
Washington, we're going to get a recent high. We're going to see
yeah
100
very
degrees
very
tomorrow.
soon, very soon it happen. And also it's not only the place that I indicated, but also overall of the world, that is will be the hottest of the year, when too much of the CH2 CH2 over of the planet, and that is problem. The combining between of the El Nino and the climate change, it makes the problem to be worse, to be it's more impacted more more problems to the nature. Thank you.
Thanks. Hui, there's a question from Hong Ben from Toy Train newspaper, where Ben asks, how bad is drought going to be in saline intrusion in the Mekong Delta? I think you went over that. So Ben, please check the video and refer back to what Hui said about this. But Ben also asks, and this is similar to a question from John Roberts, is given this information, are farmers and communities getting the information they need to adapt to this new situation? Because it's going to be dry, there's going to be less water available. Are people able to get ready for this?
So question is to Alan, right?
More for Hui or Alan. I don't know to what degree that
No, for
farmers...
me, I can provide the answer for the first question. Is that how the drought and salinity intrusion in the Mekong Delta, and then how the farmer could do to minimize the impact. Actually, we bring the experience from the two last drought. The first one, the two recent one. The one is 2016 and 2015 and 16. That the farmer is not ready for respond to the drought, and
Right.
that when it happened, it's like 18 provinces in Vietnam were affected, and that is the most damage ever of the drought in Vietnam. But in 2020, the farmer who receives the information of the prediction in advance about the El Nino will be happen, and then they delay their crop seasons and waiting until the rain season to become, and then by that way they have a less impact by drought. For the salinity intrusion, it's very difficult for providing enough water for every of the economic sector in the downstream of the Mekong Delta during of the dry season, because the water is not only depend on the rainfall in Vietnam, but also depend on rainfall in the upstream or the water discharge from the upstream of the Mekong Delta. And what they can do is that first, for the people, it's not only for the farmer, is that storing water from now, storing water in the small lake, in the reservoir, small reservoir, and also the small tanks, even in the tank in the each of the households for drinking water, for at least for 2 months or 3 months during a dry season. And it predicted that it could happen in February and January, February, and March of the next years. And the first priority is that it need have enough water for people and animals, and then the saving water from this time is my advice to the people. Thank you.
Thank you, Hui. Okay, we're going to do a few questions here, rapid fire, and then wrap up because we don't want to lose our audience, but we do have some questions to go through. One is a question from Carolyn Cowan. We're going to ask a few questions from Carolyn Cowan at Manga Bay. She asks, well, since thinking about the flooded forest, the problem is that the flooded forest doesn't get dry enough for the trees to flourish during the dry season. So if the wet season is dry and the river level's low, doesn't that give them a chance? No, it doesn't give them a chance, because it's like if you live in the Northern Hemisphere, in the United States, we have leaves that change in the fall, right? Leaves change color and then they lose their leaves. That's how deciduous trees work, and it moves into the winter. Like, you can't make the leaves lose their trees, the trees lose their leaves in the spring. You can't change the biology of these trees. These trees have evolved to the natural flow of the river system. And then even though the river levels are relatively low during the wet season, they don't get as low as what the dry season should be. I mean, the river essentially dries out to levels where islands are showing in the middle of the river during the dry season, and that just hasn't happened. Now, Carolyn has another question about, is it clear whether the lesser impacts from dams upstream in China over the past dry season was due to intentional management of dam releases, or perhaps indicative of progress on diplomacy and cooperation? Or was it more likely simply a result of natural conditions upstream? We don't know. We could speculate that the diplomacy that's happening between the downstream and China is producing results, where diplomacy is saying, like via the MRC, that dry season river lows are valued. That's something that is useful for the Tonle Sap, for the flood pulse, and that wet season higher levels are valued as well. But I think the data really point more to just a lack of rain in the previous wet season that didn't fill those reservoirs up. So there was just less water to release. Interestingly, our team provides early warning to tens of thousands of people living along the Thai-Lao border when China's dams release water or restrict water more than 50 centimeters in 24 hours. And we're able to communicate those impacts 2 to 5 days before they hit. And when we were in Chengsen last week, we actually talked to a farmer who in the past had lost his boat from one of these sudden releases. And he very proudly said to us that I'm not going to lose my boat anymore because I'm receiving alerts. He didn't know that we were the team that gives the alerts out, but it was really kind of gratifying and affirming to us that what we're doing is making a difference. What we did see over this last dry season were fewer large releases, and we issued fewer alerts, actually. And we watched the data and we saw these releases that were just under 50 centimeters, just under 50 centimeters. So sometimes we ask ourselves, are they acting that way because someone's watching on them and someone's reporting and monitoring? It'd be great if that were the case. We're going to keep up the hard work and continue to watch the river system. We're going to continue to watch and analyze how dams are impacting the river system and provide critical analysis to answer important questions like this one. And this is the one which I will leave you with. It is, how should dam operators act given this situation? Just to bring us back to what we've learned tonight. There is extreme dryness, extreme drought developing in the region throughout the basin. The Tonle Sap flood pulse is behind schedule and weak. The Tonle Sap flood pulse provides the energy for the amazing Mekong fishery. 500,000 tons of fish come out of that lake alone. 2.6 million tons of fish come out of the entire system. It's weak and it's behind. Reservoirs are at they're kind of at a very low level right now. Given these situations, how should reservoirs be operated? Should they take water out like they typically do during the wet season? Or should they let the water flow so that the downstream has a chance during the wet season? Thank you very much, everyone. On behalf of Alan, myself, Hui, big thanks to all of you. Reagan, thank you. Thanks everyone for the questions. Sorry we couldn't get to all of them tonight, but hopefully you can go back through the video recording and have some of your questions answered. We'll see you at our next seasonal briefing during the 2024 dry season. Thanks.
Thank you. Thank you,
Thank you.
everyone. Goodbye.
Thank you, everyone.